UNEP, United Nations Environment Program, listed these 12 POPs, persistent organic pollutants, with distinct environmental health concerns. However, not all countries ban all these chemicals, except dioxin and PCBs. Welcome back to the second video on pesticides and trace organics. I'm KM, an associate professor in the School of Life Sciences, Chinese University. This video will discuss the chemical structures and the toxic effects of pesticides and industrial chemicals or byproducts. US EPA was established due to the green or conservation movement advocated by Rachel Carson, who wrote this book named Silent Spring. But many chemists or toxicologists said the contents in this book is highly emotional, with little scientific contents. Regulatory toxicology relies on science and perception, rather than pure science. Yet, the harmful effects of DDT or dichloro-diphenyl trichloroethane was obvious, with biomodification effects from plankton to fish and osprey, with the concentration up from ppb to ppm levels. DDT represents a class of pesticides known as organochlorine pesticides. They are now banned in many countries as DDT damage wildlife such as the American eagle. However, they have chronic effects, but not highly toxic or carcinogenic. They are still allowed to be used in some countries to kill mosquitoes to stop malaria. Chronic effects on the nervous system, liver, kidney, and immune system in experimental animals. Adverse effects on the liver, kidney, and immune system due to DDT exposure have not been demonstrated in humans. Evidence for mutagenicity or genotoxicity is contradictory, but carcinogenicity is equivocal. They bind DNA but not causing significant carcinogenic effects. In other words, DDT is not any carcinogens. Confirmed to be environmental estrogen or hormone disruptor, DDT and its metabolites can bind to estrogen receptor. This figure shows a study of bivalves from the United States with the DDT levels over time from 1985 to 2010. As you could see that the levels of DDT in bivalves or clams with two shells are declining, but not totally eradicated. Even DDT was banned in the 70s of last century. Banning the chemicals could help, but as those are persistent chemicals, they stay in the environment for a very long period of time. The second generation of pesticides to replace organic chlorine is a group of organophosphate, OP pesticides. They degrade rapidly by hydrolysis on exposure to sunlight, air, and soil, and therefore they are not persistent in the environment, an attractive alternative, but could actually cause high toxic effects to wildlife as well, and even much more toxic than DDT. They include parathorn and marathon. When they contaminate vegetables and we consume them directly, could be deadly. Look at this case of toxic Chinese dumpling made by a patriotic Chinese wanted to kill and intoxicate Japanese. The mechanism of toxic effects of the organophosphate OP is to inactivate an enzyme in the neural pathway of an enzyme called acetylcholinesterase. Acetylcholinesterase enzyme is to stop nerve communication. Thus, OP intoxication could cause overexcitation of the nervous system. So many of these second-generation pesticides, including dichols and coparifols, are also toxic to fish and wildlife. We have to control their residue levels in vegetables. Similar to OP, carbamate also inhibit acetylcholinesterase in the nervous system. However, the carbamylation of the enzyme is unstable, and the regeneration of ACHE is relatively rapid compared with that from a phosphorylated enzyme. It is believed that carbon-made pesticides are less dangerous with regard to human exposure than organophosphate pesticides. For instance, elder crab can control mites, nematodes, and aphids in the soil. However, there are 5 to 6 million pounds of elder crab used in the US every year. However, it does inactivate ACHG in a reversible way, but it still can have high toxicity on wildlife, but no evidence of other toxicity like mutagenicity, carcinogenicity, or immune suppression effects. Natural insect repellents are also developed as pesticides, like pyrethroids such as cypermethrin, a synthetic chemical developed from the natural pyrethrins from chrysanthemum flowers. Also toxic to fish, but less toxic to human. However, a synergist of PBO, piperonal-butoxide, is often added, and it is toxic to the liver. In summary, we have developed over the last century a few generations of pesticides with significant side effects. The latest group of pesticides are known as hormone analogs. They are relatively safe because they mainly kill insects, or they are insect-specific. They are mimics of insect hormones to inhibit metamorphosis. Hopefully, they are more specific to insect and less harmful to human and fish. However, they could still be toxic to crustaceans such as lobster, shrimps, and crabs in the waters, since the mimic of juvenile hormone or JH analogs are also mimics of methylphenanthroate or a molting hormone in crustaceans. Here's an MCQ question to challenge your concept of which one of the following items is not the properties of biological effects of DDT. Accumulation in tissues, DNA binding, chronic effects in internal organs, water degradable, and estrogenic. Obviously, the answer is D, as the OC compounds are persistent organic pollutants. After talking about pesticides, we now consider other major POPs or persistent organic pollutants that are more dangerous. While pesticides have the benefits of killing off insects, the following chemicals are toxic and also carcinogenic too, and also known as endocrine disruptors. Dioxin represent a group of chemicals with similar structures and are chlorinated. There are 75 congeners in this group of chemicals, and among them, TCDD2378 or 2378 tetrachlorodibenzoyl dioxin is the most toxic chemical that human ever made. There are also dioxins and dioxin-like compounds, including the furans and PCBs. Benzoate pyrene is found in cigarette smoke and air pollutants. PCBs have no oxygen linking the two phenyl ring, whereas furans have one oxygen and dioxins have two oxygens. Benzoate pyrene has no oxygen linking the benzene rings, also acting like dioxin-like compounds, often found in dirty oil, used cooking oil, cigarette smoke, etc. Molecular mechanisms of dioxins and dioxins-like compounds. They enter the cells with their hydrophobic power and bind with a receptor called aryl hydrocarbon receptor or AH receptor, which is a gene transcription factor to induce gene expression. One famous or well-characterized gene is the cytochrome P450 or CYP1A1 gene. Its gene product is an enzyme to add an oxygen to the chemicals, making them more hydrophilic and less hydrophobic. In other words, ready to be excreted, but more active. If the chemicals are not removed quickly by other enzymes, They become active and able to bind DNA with its epoxide formed to attack DNA nucleosides, causing gene mutation and probably cancer. Examples here are benzoylpyrene and its metabolites carrying epoxide, CYP, cytochrome P450, and epoxide hydrolase can change or metabolize the chemical of benzoylpyrene. In one hand, trying to convert the chemical from hydrophobic to more hydrophilic and easier to be metabolized and eliminated. However, the process also makes benzoylpyrene from procarcinogen to a carcinogen with epoxide to form DNA adduct of benzoylpyrene diol epoxide at the center of a double helix of DNA. The DNA adducts formed could lead to point mutations at the guanine or cytosine bound nucleotides. Hence, gene mutations could happen in oncogenes to activate the oncogenes to become carcinogenic. Finally, we need to talk about waste electrical and electronic equipment. From mobile phone to electrical appliances, we contain metals and two dangerous chemicals, PBDEs and PCBs. PCB is darsine-like compound and PBDEs are flame retardants. The brominated compounds are hormone disruptors. The EU Parliament and Council already restricted these hazardous substances in electrical and electronic equipment more than 10 years ago, with 6 metals of lead, cadmium, mercury, and hexavalent chromium, and brominated biphenyl PBB and brominated diphenyl ethers PBDEs. The chemical structures of PBDEs are similar to our body's hormone known as thyroid hormone or T4 thyroxine, with 1 oxygen linking 2 phenyl rings with 4 iodine molecules linking to the rings instead of bromides in PBDE. So PBDEs could bind to T4 receptor, and initial studies already shown that PBDEs could affect thyroid hormone metabolism, and they are potential hormone disruptors too. Let's take a break and we continue on the 3rd video on metal intoxications.